Hi, I'm Kevlin Henney. The software technology that stands the test of time that I'm going to suggest is the programming language. Specifically, the concept of a programming language is a text-based notation through which we program our computers and create our systems. And also the idea of specific programming languages in general, that programming languages tend not to die. So let me start with our second one first. Whenever anybody says a programming language is dead, if you look around, you'll still see that it's alive. Perhaps it's not as active as it used to be in its youth, but normally it's still around. There's normally somewhere running that code. There is normally somebody who has created a compiler or interpreter for that, or updated an old manual. The language is alive. It may not be very lively, it may not be on a growth curve, but it's still there. And perhaps a better word than death for a language is that languages become moribund. They reach almost the point of death, but not quite. And that's a really long tail. So whenever people pick a language, you normally find, yeah, it's not dead if they say it's dead. That's just clickbait. So I'm not suggesting that we immediately all go out and find languages like PL1 and Coral 66 and things like that and start skilling up in them. But there's a difference between not really very active and completely inactive, which is dead. So the first thing is that programming languages generally do not die, they just linger. Which leads us to this other observation, that for almost as long as programming languages have existed, and the earliest programming languages that were not just straight assembler were kind of conceived of in the 1940s. And we have things like plan calcul, dating to the late 40s as a notation that was not implemented for many years and never caught on, but was highly influential. We have languages like Algol and Fortran that came from the 1950s. Algol 60 was the proper first implementation that people started using, and that we still live in its shadow in most of the languages that we use in terms of things like scope. We have languages like Lisp that was designed in the 50s and was implemented in 1960. These still linger, they are still around. You know, go and watch The Martian as a film. The code that they show in that is Lisp. If you're using Emacs, you're using Lisp. If you're using Clojure, yeah, that's a Lisp language. In other words, these are still with us. If you go and look at the current jobs, all these languages are mostly old. You don't see a lot of people recruiting for things that are not languages. Oh, those things happen. They come up every now and then as a visual system, and there's normally a bit of popularity and excitement around them for a few years, and people say, oh, you know what, we don't need to code, or you can code in English. We've seen this before, and we've seen it arrive, and we've seen it leave from the very same platform. Of course, there are points of progress. There are systems where we don't use code primarily, but they have an interesting tendency. Perhaps the most widely used programming system that does not directly use code in the way that most people use it is Excel, except that it's also got VBA. And Excel has just recently acquired Lambdas. So yeah, actually, it's a proper programming system based on a programming language, but it happens to have a convenient grid-based interaction model that most people are familiar with. So the point here is that I'm fully expecting that in another few decades, programming languages will still be there, and people will still be making the same complaints. Perhaps we could do this without programming languages. And they will discover that it turns out that the system of writing and the system of formalisms that humans have created are surprisingly effective, unreasonably so, and they're not going to go away. That's going to endure. So thank you very much, and I hope you have some thoughts about that.